All right, our third lesson here for our exponent unit, Unit 4 in 930, is combining the properties that we've learned so far. So we're going to have problems that involve all of our multiplying properties and our dividing properties. Any of them that we've done over the last 2 days could all be combined into a single problem, and those are the ones we're going to tackle. But before we do that, we're going to just look at some common mistakes that happen, some things that are easy to goof up with exponents, and make sure that you guys are really solid on all of those really common mistakes. So for all of these problems in the warm-up, there's going to be a possibility, an A and a B possibility. One of them is correct. So what you need to do is you need to look at the two and decide which one is correct for each one. So I would pause your video after each one, decide for yourself, and then watch the video to see if you were right. So the first one here, letter A, 5 to the 0 equals 0, or letter B, 5 to the 0 power equals 1. Correct answer here is B. This one is the correct one. Anything to the 0 power equals 1. So letter B was the correct, but it's really easy. You see that 0 power, it's easy to think that the answer is 0. All right, second one. 5x to the 0 power equals 5, or 5x to the 0 power equals 1. Correct answer on this one is letter A. The 0 power does not go with both bases here. There's no parentheses. So the only thing with the 0 exponent is x. The 5 has an invisible exponent of 1. So this is really like 5 to the first power times 1, which equals 5. So be careful. If it was going to all equal 1, I would have to have parentheses around the 5x so that that 0 power would go to both bases. But I do not. So A was the correct answer on this one. All right, here's the next one. Now, this one was tricky because other times we've talked about these negative number with a negative base with an exponent, we had parentheses around it. So really what you needed to watch was this really means -1 times 2 to the second power, right? There isn't a parentheses around the -2. So that is the tricky one here, okay? So be careful. If this was -2 in parentheses to the second power, that answer would be +4. But here, this is really -1 times 2 to the second. -1 times 4 gives me -4. So B was the correct answer on this one, but that was really tricky. But that's why parentheses are so important. So be careful. All right, this one's a little bit more complicated. So letter A, 2 to the third times 4 to the second. Letter A says that would equal 8 to the 5th power, and 8 to the 5th power is 32,768. Letter B is 2 to the third times 4 to the second, which they said was equals 8 times 16, which equals 128. Which one is correct? So on this one, 2 to the third times 4 to the second, these are not like bases, so I cannot combine them, right? That's not how it works. So instead, I just have to do 2 to the third power, which gives me 8, 4 to the second power, which gives me 16, and then multiply 8 times 16, which gives me 128. So B was the correct answer on this one. I cannot combine them and multiply if they don't have the same base. All right, last one here. It's very similar to the last one. So on this one, letter A, 3 to the 4th times 3 to the second equals 3 to the 6th, which is 729. Or letter B, 3 to the 4th times 3 to the second equals 9 to the 6th, which equals 531,441. All right, correct answer here is A. Remember, when you're multiplying like bases, these are like bases this time, but the base does not change. You just add the exponents and the base doesn't change. So it doesn't become 9 to the 6th. The base stays the same as 3. So A was the correct answer. All right, those were just some common mistakes for our warm-ups. So now let's take a look at some problems where we combine a bunch of properties all into one. Now here's the thing with these properties. When you have multiple properties happening in the same problem, you can do these properties in any order. I kind of have a system that I like to do. It helps me make sure that I'm not missing anything. But you know, people have different systems, and that's okay. As long as you're doing all the properties, it honestly does not matter what order you do them in. So just be careful of that. So if I look at number 1, the first thing that jumps out to me is that these are all the same base. So I should be able to use all of my properties on here because they're all the same base. The second thing that jumps out to me is that I have a 0 exponent. 6 to the 0 power, right in the middle on the top there. And I know that this becomes 1, right? And multiplying by 1 really just cancels it out. So my first thing that I usually do is to go through and see if there's anything to the 0 power and get rid of them because I don't want to carry them through when they're just going to cancel out eventually. All right, the next thing that I usually do is I look for like bases that are on the same level. So for example, I have 6 to the 2nd and I have 6 to the 3rd, both on the top. So here I'm just multiplying like bases, and those are going to stay on the top. So 6 to the 2nd times 6 to the 3rd, I'm going to add my exponents, and it's going to become 6 to the 5th on the top. The other thing that I see is I would have 6 to the 5th times 6 to the 2nd, and they're both on the bottom, same level, right? So I'm multiplying like bases on the bottom. So I'm just going to add my exponents on the bottom. So I get 6 to the 7th on the bottom. That's what I mean by on the same level. So look for like bases that are on the same level and combine them up. Now the last thing I do is I look for like bases that are on different levels. So I look for anything that's the same on the top and the bottom. And that's going to be my dividing like bases where I subtract the exponents. So I do see that these are like bases on the top and the bottom. So I'm going to subtract my exponents here, right? So I do 7 minus 5. 7 minus 5 is 2, so I have 2 6s left over. And the bigger exponent was on the bottom, so that means I'm going to have my 6 to the 2nd left on the bottom. And since there's nothing else left on the top, I put a 1 on the top because I need to make sure that that 6 to the 2nd is on the bottom of the fraction. So if that's still a little tricky for you, remember there's 5 6s on the top, there's 7 6s on the bottom. 5 of them will cancel out. There will be 2 left, and those 2 will be on the bottom of the fraction. So I have 1 over 6 to the 2nd. Now my final step is to look for any numerical bases. I see that I have 6 to the 2nd. 6 times 6 is 36, so my final answer is 1 over 36. All right, that's kind of my process for going through that. See what you can do here on number 2. All right, so on this one, I don't see any 0 exponents, so nothing to cancel out first. And I'm all on the same level no matter what, right? So in this one, I have some parentheses though. So what I'm going to do is I'm going to distribute any exponents that I can to all the bases inside. Since I am all multiplying on the inside of the first one, all multiplying inside on the second one, I can go ahead and distribute. So my first base here is -2. So I have -2 to the 3rd power. Notice I'm using parentheses, right? We remembered that from our warm-up, okay? And then my next base is a. Now this a to the 2nd to the 3rd power to a power here, I'm going to multiply those and I get a to the 6th. My next base is b, and I get b to the 3rd since it didn't have an exponent to start with. And my last base here is c. Now that did have an exponent, power to a power, so I'm going to multiply those exponents, so I get c to the 12th. All right, now I have my next set of parentheses here. So now I'm going to start distributing this 2 over here on the other one. So I have 2 to the base of 4, so this becomes 4 to the 2nd. And then I distribute my 2 to the next base, which is a. And that already had an exponent of 3, so I have to multiply again. 3 times 2 is 6, so I have a to the 6th. Notice all my numerical bases I wrote with exponents. Don't try to do the multiplying right away or you might get them goofed up, okay? So this isn't -2 times 3, it's -2 to the 3rd power. All right, so let's see what I've got here. here's a numerical base. I could convert that. Be careful. 3 negative signs, right? 3 negatives would give me a negative 2 to the third, which is 8. Negative 8 on that one. I also see I have a numerical base over here. 4 to the second is 16 over there. Okay. Now let's see. I could combine some like bases. Right here I have an a to the 6th. And then, oops, sorry guys. And another a to the 6th. Now those are, I'm just multiplying like bases, so I'm going to add those exponents together and I get a to the 12th. Now b to the 3rd, nothing to combine it with. C to the 12th, nothing to combine it with, right? But I do see now my last step here, I have negative 8, a to the 12th, b to the 3rd, c to the 12th times 16. So I have a negative 8 and a 16 that I can multiply together. So it would give me negative, let's see, 80 plus 48 is 128. So negative 128, a to the 12th, b to the 3rd, c to the 12th. And when we have that many variables, it really helps to write them in alphabetical order. It'll help you see if you get them correct. Technically, our variables could go in any order, right? Because you can change the order when multiplying. Our number always has to come in front. Coefficients come before variables. But really, to help everybody involved, you to make sure you're getting the answer right, us as teachers that help us grade them better, please write your variables in alphabetical order. Also, when you're putting answers in ClassKick or Edulastic, they will grade them correctly if you put your variables in alphabetical order. So just keep that in mind when there's a lot of variables like that. All right, only a couple left, though. Here's some more dividing ones that you can probably try to tackle. Now, what I try to make sure that I do is I always try to simplify my fraction in that parentheses before I distribute. If you distribute right away, you're going to be distributing to all kinds of terms, and it's really easy to make a mistake. So I try to narrow down the things that I have to distribute to as much as I can whenever possible. So for example, in number 3 here, I see that I have a 2 on the top and a 4 on the bottom. Now these are just coefficients, right? We talked about this yesterday. This is like the fraction 2 over 4, right? Or 2 divided by 4, however you want to think about it. This is real dividing. This isn't an exponent property. If I cover everything else up, it's just 2 over 4. How could I reduce that fraction? Well, that would reduce to 1 over 2, right? So you could write the 1 on the top, or you don't have to, but the idea is the 2 would go on the bottom. 2 over 4 becomes 1/2, or you can think of 4 divided by 2 gives me 2, and the bigger numbers on the bottom, so the 2 goes on the bottom. All right, now I also see that I have an a on the top and an a on the bottom, right? So I have a to the 2nd on the top and a to the 1st, right? That invisible 1 of exponent on the bottom. 2 a's on the top, 1 a on the bottom. When I subtract, I'm going to have 1 a left, and it's going to be on the top. Nothing to combine the b with, so I have b to the 3rd still on the top, just how it was. So I have a b to the 3rd over 2. Now, that is way less that I have to distribute to, less of a chance of making a mistake. So that's what I mean. So here I'm going to distribute my 4 on the outside to every base on the inside. So this becomes a to the 4th. Here to the b, now that I already had the exponent, so I am going to multiply, so I get b to the 12th. On the bottom, I distribute to this 2, the base of 2, so I get 2 to the 4th on the bottom. All right, now my last step is just to simplify that numerical base. So I get a to the 4th, b to the 12th, over 2, 4, 8, 16 on the bottom. All right, now technically you could distribute that 4 right away and then simplify after that, but oof, it's going to get complicated. So always simplify your fraction before you distribute that exponent. It'll save you a bunch of mistakes, I promise. You guys try it out here on number 4. Last problem. All right, so if I see what I'm going to simplify here, I see that I have 10 over 5. Now these are normal coefficients, normal numbers. These are not exponents, so I just divide them. 10 divided by 5 gives me 2. And the bigger number was on the top, so my 2 goes up on the top. Now you could think of it as the fraction 10 over 5. That reduces to 2 over 1. You could put the 1 on the bottom if you want to, but you don't have to. All right, I see that I have x's on the top and the bottom. 4 x's on the top, 6 x's on the bottom. 6 minus 4 means I'll have 2 left. The bigger exponent was on the bottom, so I'll have x to the second down at the bottom. I also see that I have some y's on the top and the bottom. 2 y's on the top, 1 y on the bottom. 2 minus 1 gives me 1 y left, and it will be on the top. So I have 2y over x squared reduced down inside those parentheses, still to the second power. So now I'm going to start distributing to each of my bases inside. So it becomes 2 to the second. And then to the base of y becomes y to the second. And then my base on the bottom, which is x to the second. Now that already had an exponent, so now I'm going to multiply those exponents and I get x to the fourth on the bottom. Last step then, numerical base. 2 to the second becomes 4. So 4y squared over x to the fourth is my final answer. All right, hopefully that kind of gave you some confidence. You're feeling okay. If you have those big fractions, simplify anything you can before you distribute if everything is inside the parentheses. Up here, just kind of find a method. Get rid of those 0 exponents right away. Be careful what you're distributing to. I like to combine things on the same level first and then work top to bottom. But remember, you can do things in any order if you want to, okay? So just remember that it's considered simplified when each variable appears only once. There are no parentheses anymore, and all fractions are in simplest form. So just keep that in mind as you're working through these multiple property type of problems.